Welcome to the DIY Honda Garage channel. The diagnostic trouble codes DTC P2729 and P2730 indicate issues with the AT automatic transmission clutch pressure control solenoid valve F in the Honda Pilot model from 2016 to 2022. DTC P2729 signifies a low input signal from the solenoid valve, while P2730 indicates a high input signal. These codes are commonly triggered by problems in the electrical circuit and are unrelated to any mechanical failures within the transmission system itself. The AT clutch pressure control solenoid valve plays a crucial role in regulating the pressure needed for proper function during gear shifts. Typically located within the transmission assembly, this component must receive accurate electrical signals to operate effectively. When diagnosing these codes, it's essential to differentiate between electrical and mechanical concerns to ensure that the correct repairs are applied. DTC P2729 indicates a low input in the AT clutch pressure control solenoid valve F, while DTC P2730 indicates a high input. Both codes highlight issues stemming from the electrical circuit interfacing with the automatic transmission control unit, TCM. The AT clutch pressure control solenoid valve is integral for managing transmission fluid pressure during gear shifts, thus ensuring smooth operation. Typically, this valve is located within the transmission casing, occupying a spot where it can efficiently deliver hydraulic pressures to the clutches. The electrical input signals must remain within specified parameters to allow the TCM to precisely control clutch engagement. Any irregularity in these signals due to wiring issues will trigger the corresponding DTCs, signaling a need for effective troubleshooting. The primary cause behind DTC P2729 and P2730 stems from issues within the electrical circuit linked to the AT clutch pressure control solenoid valve F. One potential issue could be open wires in the pressure line A, PLA, or the variable bank solenoid, VBSOL lines. These wires may become broken or disconnected, interrupting the flow of electrical signals. Additionally, shorted wiring poses another serious concern, wherein wires may have made inadvertent contact with the vehicle's body ground, causing erroneous voltage readings. Furthermore, continuous electrical faults in these circuits can lead to recurrent triggering of the DTCs even after resets. Unlike mechanical faults, addressing these electrical issues requires a systematic examination of connections and wiring integrity, ensuring that all pathways are free of damage or malfunction. Drivers may experience several symptoms when DTC P2729 or P2730 is triggered. One common sign is noticeable transmission shifting issues, where the vehicle may fail to shift gears properly or experience erratic shifts. This can lead to a rough driving experience, as the driver may feel unexpected jolts or shifts during acceleration. Additionally, the vehicle's warning light is likely to activate, alerting the driver to a problem that requires immediate attention. In some cases, transmission slipping can occur, where the engine revs without corresponding acceleration, indicating a failure in clutch engagement. If left unaddressed, these symptoms can escalate into more significant transmission failures. Hence, timely diagnosis and repair are crucial. The first troubleshooting step involves verifying the presence of the DTCs. Start by turning the vehicle to the on position. Using the HDS Honda Diagnostic System, clear the DTCs from the system. Once cleared, switch the vehicle off and return it to the lock position. After a brief pause, turn the vehicle back to the on mode again and allow a few seconds for the system to initialize. Finally, examine the HDS for any pending or confirmed DTCs. If either DTC P2729 or P2730 reappears, This indicates that the malfunction is a confirmed issue. Should neither code display, this may suggest an intermittent failure. In this case, further investigation into wiring and connections is necessary to determine underlying problems. In Step 2, we focus on checking for open wires in the PLA and VBSOL lines. Begin by turning the vehicle to the off or lock mode. Subsequently, disconnect the TCN subharness 26P connector and the TCM 58P connector. Ensure that these connections are thoroughly examined before proceeding. With the connectors disconnected, check for continuity between specific test points. The test condition requires that the vehicle remains in the off mode during this check. Specifically, you'll measure continuity between TCM subharness 26P connector pin number 1 and TCM 58P connector pin number 3, and between pin number 9 on the 26P connector and pin number 52 on the 58P connector. If continuity exists, this indicates that the PLA and VBSOL wires are intact. If continuity is not present, it indicates a need to repair any open circuits between the sensor unit and the TCM. The final troubleshooting step involves checking for shorted wires in the PLA and VBSOL lines. Again, begin by ensuring the vehicle is turned off and in the lock mode. Disconnect the previously mentioned TCM subharness 26P and TCM 58P connectors. Next, check for continuity between the specific test points and the body ground individually. Ensure that the vehicle remains off during this diagnosis. The test will specifically measure continuity from TCN 58P connector pins number 3 and number 52 to the body ground, and from the female terminals of the TCM subharness 26P connector. If continuity is present, it confirms a short to ground in the PLA and/or VBSOL wire. In this case, repairs must be conducted to rectify any shorts. If there is no continuity, the wiring is likely in good condition, and the final action would require replacing the hydraulic control unit to resolve the DTC issues. After completing all necessary repairs, it's crucial to verify the success of the repair. Begin by confirming that all repairs made have adequately addressed the issues indicated by the DTCs. Next, clear the DTCs from the vehicle's system using the HDS tool. Once this has been done, reconnect all previously disconnected connectors to ensure that the electrical pathways are secure. After reconnecting, retest the system with the HDS to check for any reoccurrence of the DTCs. Lastly, make sure to review for the presence of any new DTCs. Successful completion of this process should result in a clean diagnostic report, indicating that the transmission system is operating correctly and free from faults. Preventive maintenance is essential for avoiding recurrences of DTC P2729 and P2730. Regular inspections of electrical circuits and connections should be conducted to ensure the integrity of the wiring remains intact. It's crucial to check connectors for signs of corrosion, which can lead to intermittent electrical issues or failures. Make a habit of securing all wiring to prevent wear and potential shorts, especially in high movement areas. Additionally, keeping automatic transmission fluid at proper levels enhances performance and prevents overheating or other transmission issues. Incorporating these preventive measures will help maintain the system's reliability and extend the lifespan of the automatic transmission. In conclusion, DTC P2729 and P2730 pertain to faults within the AT clutch pressure control solenoid valve F and are primarily revolved around electrical circuit issues rather than mechanical failures. Identifying and addressing the causes of these DTCs relies heavily on a careful examination of wiring, connectors, and electrical integrity. Ensuring that all electrical connections are secure and free from damage is vital in preventing these trouble codes from reappearing. Regular preventive maintenance practices can significantly reduce the likelihood of experiencing transmission issues. Timely diagnostics and repairs can mitigate larger problems, ensuring consistent performance and reliability in the Honda Pilot's transmission system. Please like and subscribe to the channel. See you next time!